You type your bank's web address perfectly into the browser and decisively strike enter. The page loads, and it is flawless. The corporate logo is correct, the colors match perfectly, and the login boxes sit exactly right. But you are not at your bank. You are connected directly to a hacker's server, completely unaware that you are about to hand over your password. We assume that spelling a web address correctly guarantees a safe arrival. We trust the letters on our screen without a second thought. But trusting the name ignores the invisible routing system operating underneath, a system that attackers manipulate through a technique known as DNS poisoning. To understand the mechanics here, we have to look at how the internet routes traffic. Computers do not read human words. Instead, they communicate using numerical IP addresses. Because we prefer names over strings of numbers, the internet uses the domain name system, or DNS, to translate between the two. This diagram illustrates the standard process. Think of DNS as the internet's phone book. You, the human on the left, request a specific bank. The DNS phone book in the center looks up the corresponding routing number and connects you via this green line to the bank on the right. An attacker breaks this logic by secretly altering that directory. They replace the correct number inside the phone book with their own. Let's walk through an active attack. You type in your bank's address, and your computer sends out a request to find its location. Because the directory is poisoned, the DNS server replies with a fake, malicious IP address. Your browser automatically follows those bad instructions, routing your connection straight to a hacker's server, where you willingly enter your credentials. The danger lies in your browser's absolute blind trust in DNS instructions. The internet's necessary routing architecture is turned into a weapon against the user. If these networking concepts are making sense, consider subscribing to the channel. Now, where exactly does this tampering take place? It can start small, right on your own computer. A piece of malware can secretly alter your operating system's internal DNS settings. It also happens frequently at the home router. If an attacker accesses an unpatched router, they can change its settings and redirect every smart TV, phone, and laptop in that house simultaneously. The most severe attacks target a global DNS server itself. A breach at this level spreads poisoned routing information to millions of users at once. Because this tampering can originate anywhere from your personal laptop to a massive global server, relying solely on basic antivirus software on your local machine is insufficient to stop the threat. To defend yourself, start by checking your browser's built-in HTTPS secure connection indicators. If a familiar website suddenly displays a harsh security certificate warning, do not click past it. The warning is explicitly telling you the routing does not match the destination. You can also manually update your network settings to use trusted public DNS providers, which invest heavily in tamper-resistant infrastructure. Next, regularly update your home router's firmware to close the specific vulnerabilities attackers use to alter local DNS settings. And finally, modern security technologies like DNSSEC help verify that DNS responses haven't been tampered with. Think of it as a way to verify that the phone book hasn't been secretly edited. While local attacks might redirect the devices in your home, DNS poisoning can compromise the identity of the entire internet. You are typing the right name, but being handed a malicious destination. But what happens if the attacker does not fake the destination and instead simply sits invisibly in the middle of a legitimate connection? That is a man-in-the-middle attack, another interconnected layer of the same deceptive strategy. Until then, let me know in the comments, what is a scarier threat? A perfectly faked website or a silent interceptor?